In this lab, what we're going to do is we're going to determine the standard enthalpy of formation of magnesium oxide. In order to do this, we're going to be using Hess's law. Now, magnesium oxide could be formed very easily from taking strips of magnesium, such as this, and lighting it on fire. But that would be very difficult. That would be very difficult and dangerous to determine the enthalpy of formation for the magnesium oxide. Instead, what we're going to do is we're going to take magnesium, react with HCl to produce magnesium chloride. That will be one reaction. We'll determine the heat of formation, the heat of that reaction. The second reaction is we'll be taking magnesium oxide, reacting that with HCl to produce magnesium chloride and water. And then the third reaction, which we're not going to do, we're just going to take the value from literature, is 1 mole of hydrogen reacting with 1/2 mole of oxygen to produce water. And we're simply going to be using that more heat of formation for water. So the first part of this is that we need 25 milliliters of acid, and we're going to add, or we're going to determine the mass of that. Now, what I'm going to do is I'm going to tare or zero the scale with the styrofoam cup, and I'm going to add the 25 milliliters of acid to the styrofoam cup, and we want to record the mass of that. And so the mass of the HCl is 24.863 grams. Let me repeat that, please. The mass of the HCl is 24.863 grams. The next step in this process is we want to mass out the magnesium. And what we desire for the magnesium is approximately 0.25 grams. We're going to use our weigh boat, put that on the scale. We're going to zero the weigh boat, and then we're going to add our magnesium ribbons. And so our magnesium, the mass of the magnesium is 0.240. Once again, the mass of the magnesium is 0.42 grams. All right, the initial temperature of our acid is 18 degrees Celsius. And what we're going to do is we're going to add in the magnesium, and that's going to dissolve. You can kind of hear it. And what you're hearing is the magnesium reacting with the HCl to produce hydrogen gas and magnesium chloride. And so the sound you hear is that of the hydrogen gas being produced. And as you can see, you may not be able to see because of the amazing quality of this camera. Yeah, it's not focusing. Yep, I was afraid of that. But I'll tell you right now, it has surpassed 30 degrees Celsius, and it continues to rise, and it's almost up to 40 degrees Celsius, and it's continuing to rise. I'm going to stir it up, and we're going to continue doing this until all of the magnesium is dissolved in the reaction. Alright, so this has reached all the magnesium has dissolved, and it has reached a final temperature of 48 degrees Celsius. Once again, now what we have to do is we have to react the magnesium oxide with hydrochloric acid. So we need to record the mass of the hydrochloric acid. So we have, once again, a styrofoam cup. We're going to zero the styrofoam cup, and we're going to record the mass of the 25 milliliters of HCl that I just added to the solution, or to the styrofoam cup. The mass now of the HCl solution is 24.890 grams. Once again, now, instead of using magnesium, we're going to be using magnesium oxide, and I have to record the mass of the magnesium oxide. So I have my weigh boat here. I'm going to zero out my weigh boat, and I'm going to add in my magnesium oxide and the mass. And that mass should be somewhere around 0.5 grams. And so what we have here is we have 0.503 grams. We have 0.503 grams. And we're going to then add that to an HCl solution. what I have here is I have the HCl solution we just got done massing, and the temperature of this HCl solution is once again 18 degrees Celsius. I'm now going to add the magnesium oxide to the solution. If you listen very carefully, you can kind of hear a little bit. I hear just a little bit of HCl solution. Now, something to note about this is that the magnesium oxide, since it's an oxide, is not nearly as reactive as the HCl, as the magnesium metal. And that's because the magnesium metal will be in an oxidation state of 0, as opposed to the magnesium oxide, which is going to have an oxidation state of +2. So it's already given up its 2 electrons it wants to give up, and so therefore the temperature of this will not be as high. It's not as vigorous of a reaction. Now the final temperature we finally got this to is 29 degrees Celsius.